All right, 9.3 is all about holes. This is where everything from Chapter 9 is going to come together. We're going to use all our skills here at once. Let's start with this first example. Now, y is equal to x squared minus 9 divided by x plus 3. Now, you might be tempted to go with the vertical asymptote and say that the vertical asymptote is x is equal to negative 3. Right? However, this can factor. So we're going to factor the top. This factors to x plus 3, x minus 3, over x plus 3. Always factor first because, as you can see, x plus 3s are going to cancel, aren't they? So we're left with x minus 3, which now there's not a denominator. So since there's not a denominator, is there a vertical asymptote? No, nothing will make this denominator 0, so there's no vertical asymptote. What about a horizontal asymptote? Let's go back to the beginning. This is x squared divided by x. So the top exponent is bigger than the bottom. This is the scenario where m is greater than n, so that means that there's no vertical or horizontal asymptote. The same thing here. This is like divided by 1 right now, right? The top exponent x is bigger than no exponent downstairs, so it's none. All right? So pull out your calculator and let's graph this. Now, I happen to put this in beforehand because this is like take 3 of this video. I ain't gonna lie. There you go. So make sure you got parentheses around your top, parentheses around your bottom, and let's press graph. And just as some of you may have suspected, that looks like a line, and sure enough, that is a line with a slope of 1 and a y-intercept of negative 3, so our graph looks something like that. Right? But there's something weird about this graph that your calculator doesn't show you straight away. But here's the thing. Press trace. And then press, I don't know, like 8. When x is 8, press enter, you get y is 5. How about negative 5? When x is negative 5, y is negative 8. And look, there's our boy spider guy. How about 0? 0 is negative 3. Right? All right, that looks the same, but here's the thing. Put negative 3 in and watch this weirdness. Press enter. Wait a second. Spider guy vanished, and they didn't tell us a y value. There's no y value. What happened here? Well, what happened here is that a hole happened. Check this out. Press negative 3.01 and press enter. Hey, there's spider guy. How about negative 2.99? Press enter. There's spider guy again. But again, negative 3. There's a hole here, all right? And that's what happened. Because this canceled out, the original function had x plus 3, which means there's still a possible value for x that would make the original function be 0. And that value is negative 3. But it happened to cancel out. So this graph wouldn't have one, but the original does have a value that makes the denominator 0. Now here's the thing. Since the ending value does not have something that makes the denominator 0, we're going to plug in negative 3 into what remains. So negative 3 minus 3 is negative 6. And that's what's up here. If you remember, negative 2.99 was really close to negative 6, and negative 3.01 was also very close to negative 6. But that's the thing. There's a hole at negative 3, negative 6. Just like when we used to graph a piecewise function, we put that empty dot. That's what's happening here. That line doesn't go through it. You can erase your line if you got a pencil, but if I erase it, it'll do the whole thing. But anyways, there's a hole at negative 3, negative 6. Now here's the thing. If we were to plug negative 3 into the original function, what would we get? Well, negative 3 squared is 9, minus 9 is 0, divided by 0. Now some of you might think, well, 0 divided by 0, anything divided by itself is 1. Unfortunately, that's not the case, though. Some of you would think that anything divided by zero divided by anything is 0. That's not true neither. Some of you would think that when 0 is under, it's undefined. And that is closer to the truth. But regardless, what happens if it makes the denominator 0, there can't be a value there, and that's why there's a hole. So now that we know that, we got to figure out our domain and range. Well, the domain, x, is all real numbers, except what's the one thing that x is not? Except for -3. X cannot be -3, and y is all real numbers. Oops. Except -6. All right, so if it cancels out, there's a hole, and this is what this box here is going to talk about. The denominator, if a term cancels out, that's going to create a hole. All right, if it remains in the denominator, that's what makes a vertical asymptote. Now, to find the y value, I want to write this down too. To find the y value, plug x into what remains. To find the y value, plug x into what remains. All right, let's do another example here. This will start making sense here some more right now. First of all, factor. So 2x comes out, we're left with x plus 4 over, what multiplies the 8 and adds the 6? X plus 4 and x plus 2. X plus 4's cancel, and we're left with 2x over x plus 2. Can these x's cancel? No, because this is x plus 2, right? Addition messes that up. So this is what our graph is going to look like. First of all, let's talk about the horizontal asymptotes. Does this have vertical asymptotes. Does this have a vertical asymptote? Yes, it has a denominator still, and if we were to plug in -2 for the denominator, that would make that denominator 0, so it can't be -2. So I'm going to draw my asymptote at x is equal to -2. Horizontal asymptote. Let's go back to the beginning for that. We got x squared, blah, blah, divided by x squared, blah, blah, blah. So this is where m and n are equal. The top exponents are equal. So that means that y is equal to the ratio of coefficients, in this case 2 to 1. Now check this out. If we did what was left, it'd be the same thing. We got 2x and then x to the 1, so it's y is equal to the ratio of coefficients, which is still 2. So that's our other asymptote. Now, a hole. Does a hole exist here? Remember, if anything cancels out, that's what a hole is. So here, x plus 4 canceled out. So that means there's a hole at the value of x where x is -4. Now, what is the y value? You take your hole, the x value, and plug it into what remains after the canceling out. Check it out. Again, if we plug it in here, you get 16 plus -24, which is -8, plus 8 is 0. So you have to plug it into what remains here. This is -8 divided by -2, which is 4. All right, so now that we got our skeleton on what our graph is going to look like, let's graph it. Have our calculator do the rest of the work for us. Now, when you graph this, graph the original function. All right, parentheses 2x squared plus 8x. The reason being is that if you make a mistake, either from factoring or canceling out, you'll still get the right graph. And if your asymptotes don't meet up with your graph, that means that you need to go back and check your work. All right, so this looks like pseudo quadrants asymptotic quadrants 2 and 4. So that means this graph is going to look, oh, I need something like this. Something like this. Something like that. Now the hole, where does this hole exist? The hole exists at the point -4, 4, which is somewhere right there. All right. Now you can check on your graph by pressing trace and plugging in -3.99, and that's pretty close to 4, right? And then put in -4. Sure enough, there is a hole there. Right? Another way to check that you did this correctly is graph this. Or first, graph the original function. It looks like this. Then graph what you've got left. It should look exactly the same, except that it's not going to have a hole here. So that's why I like to graph the original function, so that I can see if there is a hole. All right, so that brings us back to the domain. What x values are being used? X values, everything's being used except the whole value, which is -4. So x is all real numbers except -4. And what else? Other x values not being used? The asymptote at -2. So that's our domain. Our range is all real numbers except, coming up, everything's being used except the asymptote, which is at 2. And then keep coming up the whole here at 4. All right, so holes are just an extra step. If it cancels, it makes a hole. Let's go on to number 3. Factor. Oh, snap. Well, this one's got a GCF. And then factor. The bottom, there's 4 terms, so I think I have to group this bad boy. This is going to be x squared this is going to factor to x squared minus 4 and x plus 3, which x squared minus 4 factors further to 2x plus 3, x plus 2 over okay, so in this case, 2 things cancel. X plus 2's cancel. Oops, that's a plus 3, isn't it? My bad. And the x plus 3's cancel. So what are we left with? We're left with 2 over x minus 2. All right, so now that we've got that vertical asymptote, there is a remainder in the denominator, so that means we got a vertical asymptote is x is equal to 2. Horizontal asymptote. Now, if you look at what's left, the bottom is bigger than the top, so that means it's y is equal to k. In this case, there's nothing afterwards, so it's y is equal to 0. And then our holes. How many holes does this function have? In this case, there are 2 holes. So I'm going to set up coordinates for each one. One of them occurs when x is equal to -2. And the other one occurs when x is equal to -3. So those are my x values for this. So now we got to find our y's. How do we find our y's again? You plug in your x values into what remains. So 2 divided by, when x is -2, -2 minus 2 is -4. So that would be -1/2. And then when x is -3, you got 2 divided by -5, which is -2/5. Okay. Oh, I forgot to graph my asymptotes here, right? So we got x is equal to X is equal to 2. And we got y is equal to 0, looking like this. Oops. And then graph it. Remember, graph the original. It's the only way to make sure that you're graphing the right function without, I could have made a mistake here. And I think this looks like it fits in my skeleton that I've got. So let's graph this. But there are 2 holes, and the 2 holes occur at -2, -1/2, right there, and -3, -2 fifths, which is something like right there. There are 2 holes that occur here. So our domain, the domain is x is all real numbers. I'll show you another way to write this. X is not what can't x be? X can't be -3, can't be -2. Everything else, and then the asymptote 2. So it can't be -3, can't be -2, and it can't be 2. All right, and our range is y is all real numbers except y is not. Everything's good coming up except for -1/2, -2 fifths, and then the asymptote 0. So x is not -1/2, -2 fifths, and y ain't 0. All right, so holes are just a couple of extra steps. You got to factor. If something cancels, it makes a hole. If it remains in the denominator, that is still a vertical asymptote. Bring your questions. Smith out!